Welcome all to the Max lecture series. From today class onwards, we are going to learn how to obtain the maxima minima for one independent variable and of course also two independent variables. Anyway, as I already promised that we are going to learn everything only through problems. Okay, so here also we will be directly going to check how to obtain the maxima minima only through problems. Now let us take the first question. If you observe, the question number 1 is what they told: the function f of x comma y equal to x square y minus 3xy plus 2y plus x. Now here the first step you have to cross check whether whether the function is depending on one independent variable or two independent variable. That can be directly you can cross check. Suppose f indicates function. If it is defined as simply f of x, it means f is depending on only one independent variable. No sir, this function is defined as f of x comma y, then I can say function f is depending on two independent variable. So whatever the function that is appearing inside the bracket, that is simply if it is a variable, a element x, y, z, p, q, r, if it is given like that, that is called independent variable. So here, so function f is depending on two independent variable. Now if you observe the question, in our case the given question is having two independent variable. Now we are having separate procedure. When a function is given with two independent variable, then in order to check whether the function is having local minima or maxima, the procedure will be different. If it is having one independent variable, then slightly it will be differ. Okay, anyway, given function is having two independent variable, it is very simple. What you have to do is just to take the given function, directly take the given function and then find the value of first we know this function is depending on two independent variable, one is x, another one is y. Now after identifying the independent variables x and y, differentiate this function with respect to first independent variable, again differentiate the function with respect to second independent variable. If I will differentiate this function with respect to x, it will give you 2xy minus, here it will become, here x will become 1, so minus 3y, here 2y will become 0 since we are doing the differentiation with respect to x. So while differentiating this function with respect to x, y will become automatically 0. Yes. So what we have to do is this 2y will become 0. After that the value of x will give you 1. Yes. Now by solving this function we will be getting the value for x and y. Similarly, take the second function. Again take the same function, differentiate it with respect to y. You will be obtaining one more equation. See there, if I am differentiating the function with respect to y, what are the things that will give you? X square y will give you simply x square, because while doing differentiation with respect to y, x will become constant. Second, 3xy will give you minus, since minus is there in the function, so minus 3x. Third, 2y will give you 2 only. Fourth value will become 0. Now by solving these two equations, you can obtain the value of x and y, that is x comma y. So here I can call it as x1 comma y1, x2 comma y2. Okay sir. So these 2 points we can obtain from this function. Once you obtain it, what is the next step you have to do? Once again take the same function, dou f by dou x and dou f by dou y. Now differentiate dou f by dou x with respect to one more time. You have to differentiate one more time with respect to x, such that if I will differentiate the same function one more time, then 2xy, see we are differentiating with respect to x only. So if I am differentiating this function with respect to x one more time, this will give you 2y, then this 3y will become 0, remaining rest of all are constants, so they will become 0. Take the second function, again differentiate one more time, this will give you dou square f by dou y square. If I will differentiate with respect to y, the overall term will become 0. Why? Because there is no y term, so this will become 0. And then take the function dou f by dou y, differentiate it with respect to dou f by dou x. See there, I need dou square f by dou x dou y. So now if you take that value, if you differentiate this function with respect to dou f by dou x, see dou f by dou y is there. I am going to differentiate this function with respect to dou f by dou x. So if I will differentiate, that is called dou square f by dou x dou y. What is the actual meaning of this function? You have to take the function already which is differentiated with respect to y, and then you have to again differentiate the function with respect to x. That is actual meaning of dou square f by dou x dou y. Just observe from the last which variable is given here. Y is given. Then you have to differentiate that function with respect to x such that that will give you the value of dou square f by dou x dou y. I have clearly written. Let me tell you. Take dou f by dou y whenever you want dou square f by dou x dou y. Take the value of dou f by dou y, differentiate one more time with respect to x. That will give you the value of dou square f by dou x dou y. That's all. I hope you all understood how to obtain the value of dou square f by dou x dou y. So it means you have to take the function which is given with respect to y and then differentiate it with respect to x. If you differentiate it with respect to x, what you will be obtaining? 2x minus 3. That's all. Now after that what I have to do, sir? Nothing is there. Just give some name for these functions, like I am calling it as r, I am calling it as t, I am calling it as s. It is standard. This procedure is standard. Whenever you are obtaining two independent variables, this is the procedure that you have to apply. So don't be bother about it. We are not going to teach anything new for our upcoming questions. One and only procedure for two independent variable. Okay, sir. After obtaining RTS, what I have to do? Just cross check whether the value of RT is greater than s square or the value of RT is less than s square. So if you just cross check, if the value of RT is greater than s square, then there will be a chance for local minima or maxima. That is the first one. Suppose if the value of RT is less than s square, then there is no local extremum. Directly you can make the conclusion from here. So now it is your responsibility. I have already identified the value of x and y here. Take these 2 points, substitute it in this one and this one. See, already the value of r is 2y, but the value of t is 0. What will be obtaining? R into t always will give you 0. Yes. Value of s is given 2x minus 3. Now if you observe, for x we are having two values. One is 2, another one is 1, because this is x comma y, x comma y. Okay, sir, take 2 points, both points, x equal to 2, x equal to 1. Am I right? I think, see, while solving this I got, yes, I am correct, 2, 1. So if I will substitute the value of x equal to 2, if I am substituting x equal to 2, what will be obtaining? 2 into 2 will give you 4, 4 minus 3 will give you 1. So the value of s is equal to 1 when x equal to 2. When x equal to 1, I am getting 2 into 1 minus 3 will give you minus 1. But what I want s square. S square means minus 1 whole square will give you plus 1. 1 whole square also will give you plus 1. So in both of these conditions, the value of s square is always equal to 1. Whereas the value of r into t is equal to 0. So what is the conclusion? When x equal to 2, the value of s square equal to 1. So I can write when x equal to 2, the first what I am getting is, or you can also combine all the stationary points. X equal to 2, when x equal to 2, what is the value of y? See, when x equal to 2, y equal to minus 1. I can say when x equal to 2 and y equal to minus 1, what happening is r into t is 0, whereas s square equal to 1. So 0 is less than 1 or not? Yes, sir. Similarly, when x equal to 1 and y equal to minus 1, what is the second point? Actually, I forget. Yeah, 1 comma 1 only. 1 comma 1. In that case also, see, when I am substituting x equal to 1, also what I am getting? Same. Same means r into t is again 0 only, sir, whereas s square is less than 1. In both of the cases, the value of rt is less than s square. So the conclusion is the given function is having no local extremum. It means there is no minimum point, there is no maximum point for the given function. Suppose, sir, suppose for the given function, the condition is, while cross checking the value of r into t, suppose if it is become greater than the value of s square, what should I do? Then further, next step what you have to do is directly take only r. R means dou square f upon dou x square. Cross check whether this value is, you know the value of x and y. You know the value of x and y. Of course, we are having two set of points. Substitute all those values into the value of r. Case number 1, minus 2 comma 1, case number 2, 1 comma 1. See, sorry, plus 2 minus 1 and then plus 1 plus 1. Take the first point, substitute x and y, check whether the value of r is greater than 0 or less than 0. Again, there will be one more point, right, x comma y, that is 1 comma 1. Again, check whether the value of r is greater than 0 or less than 0. Now, in both cases, sir, if the value of r become greater than 0 only, then the conclusion is, in general, the value of r is greater than 0. You can say greater than 0 means your function is having local minima. Your function is having local minima. Okay, sir. No, sir, the second conclusion what I got is the value of r is less than 0. Then you can say, no, sir, this function is having local maxima. It is not having local minima, it is having local maxima. That is how we are obtaining the value, or sorry, how we are defining local maxima and local minima for any given function. I hope you all understand this procedure, how to do this. If you don't understand, nothing to worry. One more time watch the whole lecture, just cross check whether you are obtaining local maxima or local minima. How to define this? I have clearly told you. Step number 1. Find dou f by dou y, dou f by dou x, dou f by dou y equal to 0. Obtain the values of points for x comma y. After that, again go to second order derivative. Find the value of dou square f by dou x square, dou square f by dou y square, and then dou square f by dou x dou y. And I also clearly told you how to obtain this dou square f by dou x dou y. It means what? You have to take dou f by dou y, again differentiate the function with respect to dou f by dou x. Once you completed all these things, then just to give some name for this function RTS like that, find the value of RT and S square, check whether it is greater than S square or less than S square. If it is greater than, yes, we are having local minima or maxima. No, sir, it is less than S square, then there will be no local minima or local maxima. We can simply say there is no local extremum. Suppose if this condition is satisfied, then again take the value of dou square f by dou x square, cross check whether it is greater than 0 or less than 0. If it is greater than 0, then we are having a local minima. If it is less than 0, then we are having local maxima. So this is all about, this is the standard one and only procedure that we are following in order to check whether two independent variable is having local minima or local maxima. I hope you all understood this all things completely. So with the beautiful question, in the next lecture we will be starting once again. Thank you all.